So now we are on page 2 in the notes, and we're going to start looking at how can we just start with an equation and start pulling out those key features that we just pulled out from that graph. So we're going to start with this equation. First, how do I know that this is a quadratic? It's got a degree of 2, and it is in that standard form. Y equals ax squared plus bx plus c. So what's our a value? -4. And remember, that's our leading coefficient. So our a value is -4, which means we have a negative leading coefficient. My b value is 12. And my c value is 18. So let's go ahead and figure out what it is that we know about this quadratic. Do we know where the vertex is? Nope. Do we know where the x-intercepts are? Nope. We don't know a lot at this point, except that since we have a negative leading coefficient, our graph is going to be going up and up or down and down. Down and down. It's a sad quadratic. So we know it's going to look like this. So part A says, determine whether the function has a maximum or a minimum value. Which is it if it's a sad graph? Does it have a high point or a low point? It has a high point. Not just a maximum, but an absolute maximum. That is definitely the highest point that the graph will reach. So part B says to find the axis of symmetry. So folks, we're going to write that equation for this up at the top of our page. The axis of symmetry is an x equals equation, since it's a vertical line, and we find the value it is equal to by taking -b over 2a. So this is our workaround for not being able to use our transformation rules. Instead of saying we're going up 5 and left 4, instead we can always find the axis of symmetry by using this relationship between the a value and the b value. Important box. So if we wanted to find the axis of symmetry equation for this, I'm going to say that the a of s is x equals -b. So who's our b value? The 12. So -12 divided by 2 times our a value of -4. Following PEMDAS, top of the fraction first, -12. Bottom of the fraction, since we are multiplying, gives us -8. What are we going to do with those negatives? Make them positive. They cancel out. Can I simplify 12/8? What can I take out of both of those? A 4, which will leave me with 3/2. But honestly, folks, since we're going to be using this for graphing, you can go ahead and just write it as a decimal. So 1.5. But I am not going to just circle 1.5 and say my axis of symmetry is 1.5. We have to write it as an equation that x equals 1.5. So the a of s is x equals 1.5. So what does this tell me about my graph so far? It means that the vertical line that cuts it in half is at 1.5. So I'll just draw an axis here. And we'll say this is 1, this is 2, so this would be 0. So we know that that vertical line at 1.5 is cutting it in half. Now it says to find the vertex. Do we know anything about the vertex if the axis of symmetry goes through it? What does the x value of the vertex have to be? It has to be 1.5. So we just have kind of sketched this. We don't know if this is at 1.4 or 1.520 or 1.5300, but we know that if the vertex is on that axis of symmetry line, it has to have an x value of 1.5. So folks, I would just take that 1.5 and show that that's how we get the x part of our vertex. Now for the not so great part. How do we find the y value of our vertex? We know the input. How do we find the y value or the output? Put it in the equation. I love it. So we're going to take that 1.5 and we're going to plug, whoops, drawing on my desk there. So we are going to plug this into our equation for x. So you're not always going to have to write this out, but just so you remember where the heck did the y value come from, we're going to go ahead and show what we are doing. We're going to plug 1.5 into the equation for x. So negative 4 times 1.5 squared plus 12 times 1.5 plus 18. Yuck. And now it is our calculator's time to shine. So go ahead and take out your calculators. And we are going to practice typing this in, being very careful of some of the things that we talked about in the previous unit with typing in equations. First, am I going to use a little negative in front of the 4 or a minus sign? Little negative, because I wouldn't read that as minus 4 times 1.5 squared. We'd say negative 4. So go ahead and use the little negative that's down here by the decimal point. So negative 4 times, we don't have to have those parentheses on this one, but we'll find that later these parentheses can make a whole mega world of difference. So I'm just going to go ahead and put them in. You can use the squared button, but I encourage you to still practice using the caret button, which is above the division sign. So caret button 2, and then arrow over to the right, hit your right arrow to escape the exponent and go to ground level. Then plus 12 times 1.5 plus 18. And I hit enter, and we get 27. So what did we just find? If f of 1.5 is 27, what does that tell me? That is the y coordinate of my vertex. So yeah, this little sketch that I did up here, definitely not drawn to scale, but I know that that high point, that y value, is going to be at 27. So it will have a max. It will have a vertex of 1.527 and an axis of symmetry of 1.5. We haven't made a full-on graph, but our sketch is enough to answer the next question. See if you can state the domain and range for this one using interval notation or inequality notation. What's the domain? All real numbers. All quadratics are always all real numbers. So again, you can state that as the fancy R for all real numbers, or interval notation, negative infinity to infinity. Now for the range, this is where doing the little sketch of the sad quadratic is handy. My y values start up here and are covered going down. Where do they start according to the vertex? At 27. And since it is covered going down from that point, we would say y is less than or equal to 27. So we have a relationship between the highest y value, the max, the vertex, and the range. Now, folks, a warning. If you are going to do interval notation for this one, a reminder that you have to read it from the bottom up. And so your interval starts at negative infinity and ends at 27 with a bracket. So just be careful about starting with negative infinity on that one. All right, folks. So we covered a lot of ground on that problem, and we're starting to see that with that negative b over 2a equation for the axis of symmetry and knowing what we know about polynomial key features, we can actually determine quite a bit about the quadratic. Next, we're going to see how to make the full-on graph for this. So remember, when we graphed quadratics in the past, what did we do? We used transformations to find the vertex, and then we transform the parent table. Here, since we don't know the transformations that are occurring, our steps are going to be a little bit different. You don't have to memorize these. I'm not going to say, hey, what's step number 1? What's step number 4? But you do have to know how to graph a quadratic function in standard form. Identifying A, B, and C is a good place to start. So let's go ahead and take a look at this first equation. Now, what's my A value, or the coefficient of my x squared? It is 1. So my leading coefficient is 1. My A value is 1. So since my leading coefficient is positive, is this going to be up, up, or down, down for the end behavior? Up, up. It's going to be a happy graph. So I'm just going to go ahead and draw that right here. So positive A value, positive leading coefficient, end behavior is going up and up. My B value is -4, and my C value is -5. So notice that this is just the coefficients. I don't take the x squared. I don't take the x with it. I actually like to do, well, I guess we can find the y-intercept first. Let's go ahead and talk about that y-intercept. Your y-intercept is always 0 and a number, right? Right. So if I plug 0 in, what's 0 squared? 0. What's -4 times 0? 0. So then what's my y-intercept value? It's just -5. Or your C value. So your y-intercept is always going to be equal to your C value. So what I'm going to do is I'm going to go ahead and just put a dot. Whoops, at -5, not at that +5 like I just did. Buggers. So your C value is always going to be equal to your y-intercept. So at -5. Now, does that tell me anything about the vertex? No. We don't know if that is my vertex. We don't know if my graph swooshes down here and then comes back up, or swooshes way over here and has a vertex and starts coming back up. We don't know anything about the vertex at this point. The y-intercept is just a nice, easy, exact point that we can graph. It doesn't necessarily tell us anything, though. So to finally get the shape of our graph, we have to use that equation for the axis of symmetry. So let's go ahead and highlight that equation one more time. X equals negative b over 2a, negative b over 2a, negative b over 2a. And that's where we kind of start getting more information about our graph. So let's go ahead and state what we know so far. We know our y-intercept is 0, negative 5. That was our c value. Do we know what the x-intercepts are? Not yet. Our axis of symmetry, I'm going to show my work to the right over here, is x equals negative b over 2a. Stealing those values from my equation, it would be negative 4 over 2 times my a. So we have to be careful with our double negatives here. There's a negative in the equation itself, but when b is also a negative, what's going to happen to those negatives? It turns into a plus sign. And 4 divided by 2 gives me 2. So our axis of symmetry is at x equals 2. So we're going to go ahead and draw in a vertical line at 2. Now, this starts to give us a better picture of what our graph might look like. Because we know that our vertex has to be along this line, either up here or down here. Now, if my vertex was here, to hit the y-intercept, it would have to be curving down. Would curving down make it look like a happy graph, though? No. So it kind of leads us to think that maybe our vertex is down here, somewhere lower than that y-intercept point, so that we can get the end behavior. How do we find the vertex? We take the axis of symmetry value and we plug it into our function. So to find my vertex y value, we're going to find f of 2. So we know that the x value is 2. We know that it has to be on that axis of symmetry, but we need to find the corresponding y value that goes with it. And let's go ahead and show that work above. So f of 2 is equal to 2 squared minus 4 times 2 minus 5. And we can use our calculator, but for this one, since there's no a value, it might be easier just to do it by hand. 2 times 2 is 4. Negative 4 times 2 is negative 8. And minus 5, that gives me negative 13 plus 4, or negative 9. And that's how we find the y part of the vertex. Woohoo! And now we can plot that point exactly. So forward 2, down 9. There's the vertex. Now, do we know what the end behavior is already for this graph, even though we don't know what the graph looks like? If this is a happy graph, what's my end behavior going to do? It's going to go up and up towards infinity. So let's go ahead and write that notation. We look to the left first as x goes towards negative infinity. What's my function doing? Why, it's going up towards positive infinity. And then as x goes towards positive infinity, our function is going up towards positive infinity. And you can go ahead and just draw that little happy happy face graph there. What's our domain automatically? All real numbers. Woo! So either this or this. What about the range? Do we know it without looking at the graph itself? Where do our y values start? At the y value of the vertex. They start at -9 and they're covered going up. So either y greater than or equal to -9 or bracket -9 to infinity. Now, if you didn't like doing that without the full graph, you can always wait until we do our full table of values to get the full view of what the graph like. But we can tell that just based on this information that we already have. So let's go ahead and see how we are going to get the rest of our points. We haven't done tables in a while. Yes, we did them for piecewise functions. So for the tables, we are going to do an input-output table. I am making it quite long because I don't know how many points I'm going to need. How many points did we usually want to do the shape of a quadratic? 3 was okay, just so long as you knew it was going to curve outward and not be a V like an absolute value sign. 5 was pretty darn good, but we are going to make our tables big enough to find our x-intercepts. So put a note that says, must be big enough to catch the x-intercept. So you might have to have 9 points. You might have to have 11 points. But we need to make sure that we find our x-intercepts exactly, since that's the only key feature that we haven't found yet. Now, we're not just going to plug in random things for x and figure out corresponding y values. We can't use our transformation rules to figure out what the manipulated parent table is going to look like. Instead, what we do is we center our table around that vertex point. So I'm going to put a V for vertex and put 2, -9. So we're going to center our table around our vertex. We're going to go a couple points below. So backward from 2 or left of 2, 1 and 0. And then a few points above, 3 and 4. And we are going to see what this gets us as far as inputs and outputs. Now, folks, you can use your calculator for this to plug in those values, but some of these values we might know already. Do I know what I get for an output when I plug in 0? We get that -5. We get the y-intercept. So don't forget that plugging in 0 gives you your y-intercept. But the rest of these values, ooh, it looks like we're going to have to plug these in. So let's go ahead and do the same thing that we did to find our vertex up here. I'm going to take 1 squared minus 4 times 1 minus 5. Notice that I'm using a big minus sign in front of the 4, a big minus sign in front of the 5. I want everybody to try typing this in, because your calculator is only as smart as you are, and if you can't get the right outputs here, your whole graph is going to get weird. I got -8. Anybody not get -8? Big minus signs in front of both of those. So plugging in 1 gives me -8. Now, I don't know about you, but I'm feeling kind of lazy about having to type that in every single time. I want you to write down the following helpful key sequence. second, enter. Is how we copy paste the previous line. This is a good one for the ACT folks. Anything to save you a few more seconds to do an operation. We'll give you a few more seconds to try solving one of the tougher problems. So we just saw what 1 gave me, -8. If I hit second enter, it copy pastes what I just did. And what should I now put in place of those 1s? 3s. And ooh, we got -8 again. Coincidence or not? Nah. Let's see what happens when we plug in 4. Second, enter. Override those 3s with 4s. And we get -5. Folks, what pattern do you see with your y values?
How do you delete stuff?
You can use the delete button, which is right to the left of the arrows. Or you can use the clear button to wipe out the whole line. What patterns do we see? Are you here for my leak?
Yes.
It looks like it stopped leaking, but it looks like there could be some water damage up there by that tile. It's pretty much right in the corner of that light.
Okay.
All right, folks. So as we are looking at these y values, what I want you to notice is that around that vertex, we have symmetry in the y values. So this is going to be a nice check for yourself to make sure that your vertex is correct, because if you don't get that symmetry in the y values, it means that you're not perfectly centered on that vertex. So folks, let's go ahead and plot these points and see what we're looking at. We go forward 1 and down 8, bloop. We go forward 3, down 8, bloop. And then forward 4, down 5. Don't swoosh through those points quite yet, because we do have a good shape for our quadratic, but have we found the x-intercepts yet? No. Is our graph going to hit the x-axis? Yes, it sure is. So if I swoosh through those, they're definitely going to head up and hit that x-axis. So what this means is we have to go a little bit to find our x-intercepts. So let's go another x value down and another x value up. Now, folks, here's the deal with these negatives. This is very, very important, and really the only thing that makes generating this table complicated. You have to use parentheses. So you must use parentheses when plugging in a negative number on your calculator. So you must use parentheses when plugging in a negative number on your calculator. So to find f of -1, we're going to have to trap that -1 in parentheses, square it, then subtract 4 parentheses around that -1, and subtract 5. So let's go to our calculator, and unfortunately second enter is not going to be great here because we're going to have to override with more than just simple numbers. We're going to have to put in those parentheses. So parentheses, -1 squared, arrow over to escape the exponent, minus 4 times -1 minus 5. If I press enter, we get 0. Let's see what happens if I don't use parentheses. You think we're going to get something different? Ooh, so if we don't use parentheses, we get -2. Folks, remember on the first day of school when I'm like, hey, don't get sucked into the trap of negative numbers with exponents. Here's what your calculator interprets if you don't have parentheses there.
Yeah, I entered parentheses in mine, and I got -9.
Did you use a big minus sign in front of the 4 and a big minus sign in front of the 5?
Oh, wait, I didn't put a minus sign.
So folks, there's lots of little places to go wrong here. And it's like, yes, we get to use our calculator. It's simple plug and chug. It's not really simple plug and chug because there's a lot of entry points here and there's a lot of different places where you can go wrong. So your calculator, and why we have to have parentheses here, is it's the difference between -1 squared, which is -1 times -1, or positive 1, and the difference between the opposite of 1 squared, which is -1. We have to have these parentheses in order to get the right answer for this. These parentheses here are actually not necessary because -4 times -1 is the same as -4 times parentheses -1. But the parentheses with the exponent have to be there for negative numbers. So we get a 0. That's exciting. So what should 5 also give me for an output? 0. That symmetry should hold. So once you have it established for 5 points, you can assume that your vertex is correct and it should be symmetrical for those other points. So -1, 0, thunk. 5, 0, thunk. Do we need to go any further to find my x-intercepts? We do not, because there they are. My x-intercepts are a number and 0, not to be confused with the y-intercept, which is 0 and a number. So we would say our zeros are x equals -1 and x equals 5. And we now have everything that we need key feature-wise. So let's go ahead and swoosh through to make our parabola. You gotta have the arrows on the ends. So we were a little bit sketchy about that with our transform param functions, but now that we've seen the important implication that it has on end behavior and on range, we have to have the arrows going up towards infinity. Folks, we're going to take a breather, phone break, bathroom break, before we go on to the next page.